Let's move on to reading documents. To begin our discussion of read operations, we will discuss equality searches. We'll first look at equality searches involving scalar valued fields, then nested documents, and finally on array fields. This discussion will set the stage for more sophisticated types of queries involving the rich set of operators provided by the MongoDB query language. You've already seen a couple examples of equality matches on scalar valued fields. Let's look at a couple more to get us started. For this lesson, I'd like to look at a new collection of movie data. In this collection, we have much more detail on each movie, and this will provide a good basis for a lot of the topics I'd like to look at with respect to reading documents for MongoDB. So in this example, we're querying on a single field and specifying that we want to see only documents rated PG-13. Performing the query, we can see that each document returned is in fact rated PG-13. We can get a count for the number of documents matching this query using the count command. And we can see we have 152 documents matching this query in this particular collection. We can restrict the results set further by adding additional selectors to our query document. In the MongoDB query language, we refer to the first argument to find as a query document. The fields in this document are selectors that restrict the result set to only those matching these criteria. And we can see that adding the restriction for year being equal to 2009 significantly reduces the number of documents in our result set. So what's important to notice here is that selectors in the query document for find are implicitly ANDed together, meaning that only documents matching both of these criteria are retrieved. In other lessons, we consider query operators including $or for use cases requiring documents matching any of two or more conditions. Now let's turn our attention to how we can match for equality against embedded documents, arrays, and other nested structures. Let's take a look at this document and think about some of the queries that are likely to be important in working with this data. So for example, we might be interested in only documents with a certain tomato meter rating. In case you're not familiar, Rotten Tomatoes is a movie review site. Good movies score highly on the tomato meter, with 100 being the highest. Bad movies, of course, score lower. So how would we do an equality match for, say, all movies with a Rotten Tomatoes rating of 100? In the MongoDB query language, our query would have this form. So there's a total of 34 documents matching this query. Let's take a look at a couple of them. And let's make that pretty. Here we can see tomato meter 100, tomato meter 100, and so on throughout the rest of the query results. Taking a closer look at the syntax here, we're using what we call dot notation in order to identify a field of a document nested within the field tomato. Taking a look again at our example document, you can see that at the top level of our movie details documents, we have a tomato field. And the tomato field stores a nested document with a number of fields, one of which is meter, that provides the Rotten Tomatoes tomato meter score for a given movie. Now, the dot notation syntax works for documents nested at any level. You must enclose the key in quotes. As you may be aware, it's not strictly necessary to use quotes in some clients. The shell is actually one example. So while I can do this, not putting quotes around my key here, I cannot do this. One thing I very much like about the MongoDB query language is that it's fairly intuitive in many respects. Dot notation is, in my opinion, one example. To sum up, to drive down the hierarchy of nested documents, you reach into documents at each additional level of nesting by stringing field names together using dot notation. And don't forget the quotes. Let's move on now and talk about exact matches for array fields. So far we've talked about and had several examples on how to do exact matches for scalar fields and for fields that contain nested documents. Again, we're setting the stage here for a complete understanding of the MongoDB query language, including use of a variety of operators that allow us to do a number of very sophisticated types of queries. So in considering equality matches on arrays, we can consider matches on the entire array, matches based on any element in the array, those based on a specific element, say matching only arrays whose first element match a specific criteria. We can also look at more complex matches using operators, and we will do that in another lesson. Here we're going to look at these three. In this first example, our search is going to identify documents by an exact match to an array of one or more values. Now, for these types of queries, the order of elements matters, meaning that I will only match documents that have Ethan Cohen followed by Joel Cohen, and those are the only two elements of the array writers. Just to remind ourselves what the documents look like again, let's look at our example one more time. And here we find our writers component of this document. Note that writers is an array, and the documents in this collection may have one or more writers. So let's run this query. So we get one document, and let's actually take a look at what the document is. In this data set, there is one movie that matches these criteria, The Big Lebowski. Note that it has an array field, writers, that have Ethan Cohen and Joel Cohen listed in the order we specified here. Note that due to the semantics of array matches, the following does not match the same document, or in fact any documents in this data set, because we've switched the order of the writers. Now, I think it's more common that we match documents for which a single element of the array matches selectors in our query. Here's an example. The semantics of this query are that document matches will be those that contain the string Jeff Bridges as one element of the array actors. No other constraints are placed on the query results. And you can see that, in fact, Jeff Bridges does occur in this document, and this one, and for the other results retrieved by this query. What's nice about this syntax is that it's exactly the same as selectors for scalar values. People just learning to use MongoDB sometimes forget that. Just be aware that in your query, you don't need to enclose the value you're looking for in an array field or square brackets, unless you actually want to do an exact match on the entire array value for documents in your collection, as we did with the Cohen brothers example. So again, just to sum up, if you have an array field and you want to find all documents where any element in that array field matches a specific value, you can do a query of this form. That will locate all documents where the string we supplied, in this case Jeff Bridges, is any one of the elements in this array. In some situations, we want to match a specific element of an array. Actors and writers are frequently listed in some sort of order of precedence, with those whose contributions to a film that are highest occurring earlier in a list. For example, the star of a movie will appear before supporting actors, as we see in this document for Iron Man, in which Robert Downey Jr. starred and Jeff Bridges provided a supporting role. In our dataset, this type of ordering is, for the most part, an implicit part of all array fields. The MongoDB query language enables us to specify that we want to match array elements occurring in a specific position in an array. So in this dataset, we might be interested only in those movies where Jeff Bridges was the star. In this case, that means he's likely to occur as the first actor listed. Now, the way to do this in MongoDB is to use dot notation, similar to what we do with embedded documents. But in this case, we specify the element of the array in which we're interested. And if we do this query, we'll see that we get two documents back, one for The Big Lebowski and one for Crazy Heart. So before, where we had 4 movies returned for our search, we now have 2. Again, those being the movies in which Jeff Bridges stars. So now we've looked at equality matches on arrays against the entire array, matching any element of the array, and then those based on a specific element. For example, the first element of an array. We discuss other aspects of querying against arrays in later lessons. In addition to arrays, we discussed equality matches on scalar valued fields and on embedded documents. This discussion provides a good foundation on the MongoDB query language. You should now have a solid understanding of the syntax for reading documents in MongoDB. Before we wrap up this lesson, there are 2 additional topics that are important here for understanding reads in the MongoDB query language. Before we wrap up, I want to discuss cursors and projection. With regard to cursors, as we discussed in another lesson, the find method returns a cursor. To access documents, you need to iterate through the cursor. In the Mongo shell, if we don't assign the return value from find to a variable using the var keyword, the cursor is automatically iterated up to 20 times to print an initial set of search results, as we see here in response to this query. In general, the MongoDB server returns the query results in batches. Now, batch size will not exceed the maximum BSON document size, and for most queries, the first batch returns 101 documents or just enough documents to exceed 1 megabyte. Subsequent batches will be 4 megabytes. Now, it's possible to override the default batch size, but that's out of scope for this class. As we iterate through the cursor and reach the end of the return batch, if there are more results, cursor.next will perform a getMore operation to retrieve the next batch. Now, since these documents are relatively small, our initial batch is going to be 101 documents. So by typing IT repeatedly here at the cursor, we've just iterated through 2 batches. The first one with 101 documents and then a second one composed of just 7 documents. Now, if you want to see how many documents remain in a batch as you iterate through the cursor, or just in general look more closely at how cursors work in the shell, you can do something like the following. So first, we'll assign our cursor to a variable using the var keyword. Next, we'll create a function that uses this cursor, checking first to see whether there are any more results, and if there are, getting the next one, otherwise returning null. Now, before we do anything, we can check to see how many objects are in our batch by using this method on our cursor object. And we can see that, in fact, we do have 101 documents in this initial batch. I can iterate through this batch by calling this doc function that I set up. And then I can call this method again to see how many documents are left in our batch. Now, if you're particularly interested in cursors, I'd encourage you to have a look at the MongoDB documentation on cursors at docs.mongodb.org. Now, last but certainly not least in this lesson is a discussion of projection. Projection is a handy way of reducing the size of the data returned for any one query. As we know, by default, MongoDB returns all fields in all matching documents for queries. To limit the amount of data that MongoDB sends to your application, you can include projections in your queries. Projections reduce network overhead and processing requirements by limiting the fields that are returned in results documents. Now, projections are supplied as the second argument to the find command. Now, if I want to limit my documents so that they just contain a title, I can do that using this, or almost. Now, you'll see that instead of returning all of the fields for all of the documents that match, now I get just the title. I also get the _ID field, so let's talk about why that's true. The projection syntax allows me to explicitly include fields in documents returned. I can also explicitly exclude fields. If I explicitly include fields, those are the only fields that will be returned. The one exception is _ID. _ID is always returned by default. If I don't want to see _ID in return documents, I need to explicitly exclude it. And I can do that by simply specifying a 0 for ID in my projection document. And now we see that we just have titles. And as we iterate through, all of our results merely contain titles. Now, if we have the reverse situation where we actually want to explicitly exclude a couple of fields, we can do that as follows. So rather than include title, I'm going to exclude writers and actors. Now, my results contain all fields except for the ones I explicitly excluded here. And you see, if we scroll up, where we used to find writers and actors, we don't find any fields at all now. So if you need to limit the fields returned by your queries, projection is the tool to use.